Hello, I'm Noan, and today I'm going to present my advanced Capstone project, where we have to create a machine learning model to predict useful information. The topic I chose is to track COVID death increases using not only COVID numbers, but also TSA travel data. So let's get right into it. All right. So let's talk about the data sets. I use two data sets. The COVID tracking project is the first one. As you can see in the top left, that I'm using the totals for the US totals. This is a public data set, and you can get data from in the form of CSV or through using an API. You can see the link below is the data set. And on the right, you can see the data set itself, which has one row for each date, and it has different features such as death increase, and a bunch of variety, including like hospitalized increase and such. And I'll be using death increase as my target for prediction, and the death increase like in the future. So I'm using data from the past to predict the future. All right, let's go to the next slide. The next data set is the TSA travel data. And this page, as you can see, is updated 9 a.m. daily. So again, it's the same dates. And you can see the columns is 2021, 2020, and 2019 from left to right. This keeps track of the travelers that are going past TSA checkpoints. And this is, again, a public data set that I web scrapped. You can see the link below is the tsa.government. So you can see that the numbers are decreasing from right to left because of COVID, obviously. Yep. All right, so let's talk about the use case. And this is a problem that inspired me to choose this topic specifically. And that is hospital accommodation, because the overflow or overcrowding of patients in hospitals. As a hospital, it's very hard to prepare for the numbers that we're seeing during this pandemic. So what we need is so it's really hard to accommodate for all of these patients. So using this model, the COVID death tracking, which I think would be a really good indicator of the number of cases that would come in, hospitals can better prepare for a number of patients. Yeah. So here's the solution. So we will be predicting the daily trend using the Keras model, and specifically using the LSTM layers. You can see on the graph on the left is actual death increase over predicted death increase. And you can see that the best fit line is very close to y equals x line, which is completely diagonal. And what this means is that each of these x and y values are very close to each other, which means that the actual and predicted are actually very similar. Therefore, you can see at the bottom as well that the correlation between the two results, the predicted and the real, is very high. So although this might not be able to predict very specific, like how many people are going to go to the hospital or how many people are going to die because of COVID, this can provide for a general trend. All right, so let's now talk about more data science specific information. So architectural choices, the data sources I already talked about, the COVID tracking project and the TSA travel data. The links are provided here. But also the ETL, feature engineering, model definition, training, and evaluating are all done in IBM Watson Studio, specifically the Jupyter Notebook, because it gives me access to cloud object storage, Spark, specifically Spark data frame, which allows me to join the data. Cloud object storage, I can store a lot of the pre-processed processed data, as well as load all these data, and as well as the models. And the Keras TensorFlow obviously lets me build the model itself using the LSTM layers that Keras provides. For scikit-learn, I use the scaler, specifically the min-max scaler, for better model performance. So yeah, IBM Watson Studio really helped because it provided all of these essential tools that I needed. So model performance indicators. The graph and the correlation we already talked about, but for the training model I ran for 50 epochs, and I used the MAE as the loss function, or the loss metric. So you can see that the loss was actually really, really low, which is really good. But during the evaluating model, you can see that the loss was actually much higher at like 10%. So this shows that there's model like overfitting. However, this 10% is still a relatively good result. So even if it's overfitting, I believe it can generalize to a good degree. So the model algorithm, I use the input layer, I guess. Two LSTM layers, one with 1 unit, one with 10 units, and the dense layer, which is kind of like the output layer. The input layer, I had 17 features, and the 7 is the time step for the time series prediction. And this is a really, really bad visualization. But basically, I'm looking at a 2-week period. I'm using the first 7 days to predict the next 7 days, to predict numbers for the next 7 days. And this is basically time series prediction. And that's the time step, which is 7, which gives me the extra dimension of 7. For the LSTM layers, I'm using the stateful LSTM, which lets me initialize the states of the next cells using previous cells. Because this is a time series prediction, each of the data will be somewhat related to the data from before, since it's like a gradual transition. And therefore, stateful LSTM is very useful in this time. All right, that is the end for now, because it's only the end for now because, as you can see, there's a lot of room for improvement. You can see that there was like the model algorithm was not too complicated, as there was only really 2 layers. And also the correlation, although the correlation might be high, the actual predictions were still a little off, and you can see that the model was also overfitting a little. So there's definitely room for improvement, but that's the end for now. All right, thank you.